Thanks so much, and for the introduction, and for Azu, Saurabh, and Alexander for putting this together. And I think Azu's warm up here was a perfect setup for this. What I want to talk about is how social networks are changing and how that's affecting our ability to learn, and what kinds of things we can do about that in terms of the media and content moderation that Alexander was just mentioning. And I want to just point out in this 15 minutes, two major things that we face in learning. And one is, as many people are aware of, is sort of disinformation and misinformation. And I think one key to understanding this and why things are different now than they were before is that social media are increasing the breadth and depth of our networks. And I'll try and make that explicit in terms of what the impacts of that are. And one way that we can begin to deal with this is trimming networks in an informed way. So we can begin to limit the way that people can forward things. We can limit the way that messages travel. And by doing that, we can avoid censoring the actual content of these, which I think is a dangerous avenue. The second thing I want to talk about is the sort of echo chamber thing that people usually refer to, which is that networks are distorted and biased. We have a lot of homophily. We're often in contact with people who have similar viewpoints. And that, I think, an important aspect of what's happening right now is that's actually exacerbated by the design of social media and by competition in social media markets. And I think one way we can get around that is by building bridges and new links from people to outside of their usual networks. And I'll talk a little bit about what the competition problems are there. And let me just start with a couple quotes here. One from Elizabeth Warren, talking about the safety of our democracy and the importance of social media to try and take care of disinformation. And then the counter quote from Mark Zuckerberg saying that Facebook and internet platforms in general shouldn't be arbiters of truth. And I think that there's a good reason that we should be careful about censoring and trying to moderate the actual content of messages. And I think no matter who does it, whether it's a government, whether it's private, whether it's crowdsourcing, all of these have biases. And there's going to be biases inherent. There might be deliberate kinds of censoring issues. There's also huge volumes, and trying to arbitrate what's true and what's false is not easy in real time. Messages travel quickly, things move quickly. Algorithms have had a hard time with satire and humor and deciding what is true and what's not true. And so I think one important point is that we can do things to improve the content and the way that people learn without actually policing what's inside. And so I want to sort of talk a little bit about that. I'll sort of set this up. So if information is being relayed through social media and through long chains, there's a bunch of ways in which it can get distorted. And how can we understand whether people can learn and what we can do to improve this? And I think one thing that's sort of important here is that design systems have certain structures to them. So if you're actually not working on a hardware system where you want to make sure that signals get through without distortion, you put in lots of redundancy. You try and build things with low distances, low loss, high fidelity. Whereas when we look at social systems, there is some redundancy, but things actually travel remarkably long distances. There can be high loss and low to medium fidelity. So there can be a lot more noise in a social system than in a design system. And actually, I'm going to pull a figure. This is from something that John Kleinberg did, Lyman Newell and Kleinberg, from a little more than a decade ago. And they just traced out some chain letters and looked at these things and sort of so what I want to illustrate with these things is, these are, when you're looking at this long tree here, this is actually the paths that these chain letters followed. And we all talk about, 6 degrees of separation and small worlds and so forth. The remarkable things about these kinds of pictures is that the messages can travel huge distances. So it's not as if they traveled 5 degrees to get to their end user. They could be traveling a long distance, and actually here the median node depth is 288. So things can be moving a lot longer and traveling a lot further. And one thing that happens along the way, and this is just an example of some of the kind of mutations that arise from Lada Adamic's work, a group at Facebook looking at memes. And they started with some particular meme, and then they traced memes. And so they traced a bunch of memes through Facebook. And one started out, no one should die because they cannot afford healthcare. No one should go broke because they can get started. If you agree, post this to your status. And what happened was people would post it, but then people would alter it. They would change it to something else that they wanted to say. And then it would go to the next person and it would get altered. And when they looked at it, it was posted 470,000 times. Mutation rate was about 11%. The times when you reposted, you changed it. And there were, in the end, more than 100,000 variants. And out of the 123 largest variants memes that they looked at, 121 had more than 100,000 variants. So this isn't something that's small. There's a lot of mutation going on, a lot of doctoring of the messages, repackaging of messages, and so by the time it gets to somebody, it could be almost completely different from what we started with. And so let me just mention some work I did with Suraj Maladi and David McAdams. And here's a picture from an old Norman Rockwell kind of telephone context where by the time messages can travel and they can mutate. Here in social media, they can be traveling longer distances and a lot of noise can be building up. And so I want to sort of mention the types of noise just to fix things. One is the kinds of mutations we just saw in the Facebook context. Another is biased forwarding. So it's people forward things that are sensational. There's evidence that things that are false might be forwarded more rapidly and further than things that are true. There's deliberate broadcasting of false news and so forth. And that's going to tend to build up. The longer the distance things have to travel, the more chance you have for mutations, the more chance you have that somebody in the intermediate was broadcasting something they deliberately wanted to. And so shorter chains are going to have higher fidelity, longer chains are going to begin to build up more noise. Okay, so what would you like? You'd like to have many chains, but shorter or better. And so in that paper, what we do is we just look at a setting where there's a bunch of, there's a learner here, and that learner is getting information coming through a network. And from the learner's perspective, think of this as that, they're at the root of a tree and information is flowing to them from all these far sources. And along the way, things can distort. And so things that have traveled a long distance are going to tend to have a higher chance of mutating than the ones that have come a short distance. So as we have these more intermediaries, each one of those intermediaries can distort things, add their own perspective and so forth. And by the time it gets to the learner, the message could be quite different than the original content. And one thing that's sort of important is, okay, so how do we, one way we could just track all these messages and try and censor them. The other way is just to realize that the ones that are far are much more noisy and the ones that are closer are going to have higher fidelity. And so, when we look at the ratio of far messages to the close messages, there's two different things that control what the ratio of far to near is. And that's the ratio of noisy to less noisy is. When we look at the average degree, this D, so that's sort of, am I talking to 2 people? Am I talking to 500 people? Am I broadcasting through Twitter to thousands of people, or am I broadcasting to 2 friends that I'm talking in conversation? So what happens is, if we're looking at some distance T compared to some shorter distance little t, the amount of noise that has a chance to build up is this D raised to the T minus T power, right? So it's growing exponentially in the distance, and it's the D raised to this power. So the higher the breadth and the longer the length, the more we have a chance of noisy messages compared to close messages. So this is just really simple, calculus. Effectively here, if we wanted to control the ratio of far to close, what we can do is just limit the T. That's one way to do it. So if we could just track how far messages have gone and said, look, after something's been forwarded 3 times, we're going to cut it off. That would be one possibility, or just put a cap on it. With encrypted messages and other kinds of things, that gets a little tricky to do. So sometimes it might be impractical on some platforms to just limit the distance things can travel. The other possibility is actually to cut D. So we just cut the number of people that you can forward something to. And in fact, WhatsApp has done that. Facebook has done that with the Messenger now. Those are kept at 5. So instead of just broadcasting it to everybody, you can only broadcast it to 5 people. You can get around that by rebroadcasting it, but then that takes more effort and cost. And so it means that people can't just hit a button and broadcast it to thousands of people. That limits the breadth of this tree, and that increases the ratio of close compared to far messages. So, if you just go through a very simple model of this, that improves the learning, and you can actually optimize what's the optimal D, what's the optimal T, to make sure that the ratio of messages and the number of messages that somebody's receiving are optimized for learning. So that's something you can do without actually going into the content of the messages, just realizing that they're going to be distorted at certain rates, that certain ones are going to be passed along with more probability than others. Just controlling the tree will actually improve the learning structure. Okay, so basically here we can limit the T, or we can cut the D, and as I mentioned, WhatsApp recently capped their D at 5, Facebook Messenger capped their D at 5 as well. So we have examples of this. These are crude, simple caps, but they can improve the fidelity in learning, and it avoids censoring. So that's an important thing. Okay, what's the problem with all this? Just in the couple of minutes we have left, the problem with all of this is this kind of picture, which is homophily, right? So these networks are not networks where all the different sources are uncorrelated in terms of the content they're generating. This is a picture from a high school friendships, but the basic point, and these are color coded by race. This is from a study I did some years ago with Sergio Carini and Paulo Pin. We're just looking at friendships inside a high school by race, and we see a strong segregation in those networks. But that kind of segregation occurs along all kinds of dimensions: political ideology, religion, age, profession, and so forth. You split people up that way, and so that means that if we start limiting people's networks, they're going to be getting most of their information from more local sources, and those more local sources are going to end up being people who have the same demographic characteristics as them, the same ideological characteristics as them. So they might end up with very limited information and noise. And this gets back to I think the paper that Azu mentioned. This is a more recent version by the Bakshi, Messing, and Adamic paper. And it just looks at the viewer affiliation, and then the liberals are the blues here, the reds are the conservatives, and then they just looked at the percent of cross-cutting content that you could be exposed to. And I think this graph is really striking, right? So if you just mixed everything up and you were getting things randomly from the network, if you were liberal, 45% of the stuff you saw would be conservative. And if you were conservative, 40% of the stuff you saw would be liberal. So you'd actually be getting a balanced news feed. But then when you put it in the potential from the network, meaning who are your friends, that begins to limit stuff, and these numbers go down. And then what you're actually exposed to once the algorithm is picking what content you're seeing, that's a further selection. And then what you actually click on is a further selection. So when you go through these filters, by the time you get down to it, the content you're seeing, so for instance, from the 45, you're down to 20% cross-cutting content, right? So that really limits things. And I think that, in terms of thoughts, what's happening here is modern media are upping the size of these trees. So the fact that we have social media, and what's different about this world is they're upping the size of these trees. They're upping the number of people that we can be hearing from, but they're also increasing the homophily at the same time. So they can be connecting us and selecting what we're going to hear. Trimming networks can improve fidelity, but to overcome this kind of homophily problem, what we need to do is build bridges that go longer distances. So create links that go from people to other people, bridge those networks from one group to another. And I think one important point, and I think that we'll talk about this in much more detail in our discussion later on with Alexander. I think the competition can actually exacerbate homophily in these biases. And what do I mean by that? So I think when we think about platforms, what would be wonderful is if a platform said, look, your news feed is biased. You're not, you're getting things only from a certain distance. What we're going to do is start posting some things here that you might not be exposed to. So we'll add a feed that says, okay, what's going on in the UK? What is the highest reposted things in the UK? What's going on in Texas? What's going on in Maine today? You can click on these and so forth. What's the problem with that? People tend not to want to click on that, and they find that content less engaging. And if you're in competition for users, you want to find the stuff that people are going to click on. You want to find the friends that they're going to want to connect with. You want to connect them to the things that they want. And people's tendency are to look for people who have like minds, that are saying things that resonate with them. So that's going to exacerbate homophily and these biases rather than building it across. And so I think this is one place where competition actually can be hurtful in terms of what happens in terms of the structure of these networks. And I think there's a lot for us to understand in that direction.